Hi student, in this video I will show you how to solve absolute value inequalities in one variable. Here we have equivalent form. Number 1, if we have modulus x less than p, we can write as x less than p greater than negative p. Okay, number 2, if we have modulus x greater than p, so we can write as x greater than p and x less than negative p. So now let's move to first example. Okay, if we have modulus 2x plus 5 greater equal to 15. So our absolute value actually in form of number 1 and 2. Okay, we have greater than or equal to 15. So we can write as 2x plus 5 greater than equal to 15, and another one, 2x plus 5 less than or equal to negative 15. And then we can solve one by one. For the first inequalities, we have a linear inequalities, so we can bring the term with variable to one side and constant to one side. So we can write 2x greater than equal to 10, x greater equal to 5. And the second inequalities, we have 2x plus 5 less than equal to 15, so 2x less than or equal to negative 15 minus 5, negative 20, and then x less than equal to negative 10. And then we can write solution. To x less than equal to negative 10 and x greater equal to 5. Okay, next, second example. We have modulus 2x minus 7 minus 12 less than 25. So we need to simplify this absolute value equation first, inequalities first. So we have modulus 2x minus 7 less than 25 plus 12. Means you bring a constant to one side. We get 2x minus 7 less than 37, and then from this we can write this absolute value inequalities equal to, since we have less than symbol, so you can write 2x minus 7 less than 37 greater than negative 37, and then solve. We have 2x less than 37 plus 7 greater than negative 37 plus 7. We get 2x less than 44 greater than negative 30, and then solve for x. We get x less than 44 divided by 2 greater than negative 30 divided by 2, so we get x less than 22 greater than negative 15. Okay, next. Okay, example number 3. We have modulus 2x plus 1 over x minus 2 less than equal to 2. So this absolute value inequalities actually equivalent to 2x plus 1 over x minus 2 less than equal to 2 greater than equal to negative 2. But we can't solve directly. We can multiply x minus 2 with 2 because this is unknown. We have variable here. So what we can do here, we can split the inequalities. So we can write the first one 2x plus 1 over x minus 2 less than equal to 2, and another one 2x plus 1 over x minus 2 greater than equal to negative 2. So we can solve one by one. So now actually here we have rational inequalities. So you need to write in standard form. So just bring all term to left hand side. So we get 2x plus 1 over x minus 2 less than equal to 0. We get 2x plus 1 over x minus 2 times x minus 2 over x minus 2 less than equal to 0, and then expand. We get 2x plus 1 minus 2x plus 4 over x minus 2 less than equal to 0. Okay, and then we can simplify. We get 5 over x minus 2 less than equal to 0. Where from these inequalities, we know that based on denominator, x must not equal to 2. And for critical value, since our numerator is constant, so we can find a critical value at denominator. The value x minus 2 equal to 0, so x equal to 2. So we just have one critical value, that is x equal to 2. So from this critical value, we can form an interval. We have x equal to 2, so we have two intervals. The first one start from negative infinity to 2, and the second one start from 2 to positive infinity. And then we have interval, test value, and the last column sign of, okay, we have 5 over x minus 2. For the first interval, we have negative infinity to test value. You can choose x equal to 0, and numerator we have constant 5, means always positive. Okay, positive, and then denominator negative equal to negative sign. And then second interval start from 2 to positive infinity, so we can choose x equal to 3. So numerator positive, denominator also positive equal to positive sign. So from this table, since our inequality symbol is actually less than equal to 0, means we will use close bracket, and then less than mean we will choose the first interval, and then you need to check, since our denominator x minus 2 must not equal to 0, mean x must not equal to 2. So our solution here in interval form will become equal to from negative infinity to 2. And open bracket, not close bracket. Okay, next. Next, we have 2x plus 1 over x minus 2 greater and equal to negative 2. So just bring negative 2 to left hand side. Get 2x plus 1 over x minus 2. Okay, plus 2 greater equal to 0. And then solve. So we get 2x plus 1 plus 2 times x minus 2 over x minus 2 greater equal to 0. And then simplify. So we get 2x plus 1 plus 2x minus 4 over x minus 2 greater equal to 0. Or we get 4x minus 3 over x minus 2 greater equal to 0. Okay, from these inequalities or rational inequalities, we know that x must not equal to 2. Means x minus 2 must not equal to 0. So x must not equal to 2. And for critical values, from numerator, okay. From numerator, we have for x minus 3 equal to 0, x equal to 3 over 4. And the second one, at denominator, x minus 2 equal to 0, x equal to 2. So we have two critical values, 3 over 4 and 2. So from real number line, 3 over 4 and 2. So we will have 3 interval. So the first one start from negative infinity to 3 over 4. Second interval start from 3 over 4 to, and third interval start from 2 to positive infinity. So we have interval. Interval, test value, and signs of, okay, our inequalities for x minus 3 over x minus 2, and our sign is greater than or equal to. Greater than equal to 0. So for the first interval, we have negative infinity 3 over 4. So we can choose x equal to 0, and then at numerator, if we substitute x equal to 0, we get negative sign, denominator negative sign equal to positive sign. And then second interval, we have 3 over 4, 2, and we can choose x equal to 1, and then substitute numerator equal to positive, denominator equal to negative, equal to negative sign. And then third interval from 2 to positive infinity. So you can choose x equal to 3 and then substitute, we get positive over positive equal to positive sign. So since our inequality sign is greater than equal to 0, we will use close bracket. Okay, positive mean we choose positive sign, first and third interval. So we can write our solution in interval form. This is a solution for this inequalities only, equal to negative infinity, and then you need to check our denominator must not equal to 2, so 3 over 4 you can use close bracket. And then union third interval 2 open bracket 2 to positive infinity. But this is not the solution for our question that is our question. We have modulus 2x plus 1 over x minus 2 less than equal to 2. So how to find this solution? Actually, from both interval that we get, for the first problem we get, first inequality we get from negative infinity to 2, and then for second inequalities, our solution is from negative infinity to 3 over 4 union 2 to positive infinity. So how to find the solution? You can sketch a real number line. You can sketch a solution based on real number line. Okay. For the first solution is from negative infinity to 2. Okay, I write here. The first one is from negative infinity to 2, open bracket. The second one is from negative infinity to 3 over 4, close bracket, union 2 to positive infinity. Okay, how we want to find the solution based on these two interval? Okay, the first we have 3 over 4 and 2. Okay, the first one we have negative infinity to 2, means you can write as x less than 2. Okay, and for number 2, actually the first one in equality form, x less than or equal to 3 over 4 and x greater than 2. So how to sketch on the number line? So the first one, x less than 2, we use a white dot here, less than 2. This for the first one, and then the second one we have x less than or equal to 3 over 4 and black dot. And then the third one we have x greater than 2 and white dot. Okay, based on this real number line, we will choose the interval that satisfies both rational function or rational inequalities. So based on this the number line, the interval that satisfies is actually from here. We have intersection here. So the solution for modulus, if solution for modulus 2x plus 1 over x minus 2 less than equal to 2 is actually x, we have black dots mean less than equal to 3 over 4. So this is the final answer. Okay, thank you.